Come and stand with me here on the edge of the desert. As the sun begins to set over the Giza Plateau, feel the cooling air and watch as the sky turns to a deep bruised purple. Before us stands a shape that is so familiar it has become an abstraction, an icon on a postcard, a symbol of a long dead world. But try for a moment to see it for what it truly is. A mountain, a perfect man-made mountain of stone, so vast, so ancient, and so profoundly silent that it seems to defy not only the laws of engineering, but the very passage of time itself. For 4,500 years it has stood here, an act of sheer defiant permanence in a world that is destined to change and decay. It has watched empires rise and fall. It has seen languages born and then turn to dust. It has felt the sands of the Sahara shift and crawl around its base for millennia. And through it all, it has remained a colossal, silent question, written in a language of pure geometry against the sky. How did a civilization armed with only the simplest of tools and the strength of human muscle achieve this? How did they quarry and move and lift and place millions of multi-ton stones with a precision that we, with all of our modern technology, would find difficult to replicate? This is not a story of what we know. It is a story of what we have forgotten, an exploration of a profound and enduring mystery, a journey in search of the lost engineering of the pyramids. Before we journey further, feel free to leave a comment with from what location you're watching this, and what time it is there. Now, settle in, as our exploration truly begins. The scale of the Great Pyramid of Khufu, the largest of the Giza pyramids, is a thing that is almost impossible for the human mind to truly comprehend. We must begin with the numbers, but the numbers themselves are so colossal they become a form of poetry. The structure is composed of an estimated 2.3 million individual blocks of stone. The total weight of this single building is nearly 6 million tons, a mass equivalent to more than 10 of the world's largest fully loaded aircraft carriers, stacked one on top of the other. The average weight of a single one of these limestone blocks is 2.5 tons, the same as a large modern SUV. And this mountain was assembled with a level of precision that is simply breathtaking. Its base, which covers 13 acres, is level to within less than an inch, and its four sides are aligned almost perfectly to the four cardinal points of the compass, with an error of less than 1/10 of a single degree, a feat of surveying that would be a profound challenge even today. This was not a crude pile of rocks. It was a work of immense and almost supernatural precision. The first, and perhaps most fundamental, question in this great mystery is the question of the source. Before a single stone could be lifted, it had to be cut and freed from the living rock of the earth. The vast majority of the pyramid's great limestone blocks were quarried directly from the Giza Plateau itself, in a vast open-pit quarry located just to the south of the great structure. Today it is a hollowed-out crescent-shaped depression in the landscape, a silent and empty amphitheater that bears the scars of an almost unimaginable industrial effort. Walking through this ancient quarry, one can see the evidence of the work, the faint parallel lines of the channels that were cut to isolate the great blocks, the curved marks of the copper tools that were used to shape the stone. But the evidence only deepens the mystery. The ancient Egyptians had no iron, no steel. Their primary tools were chisels made of soft copper and hammers made of a hard stone called dolerite. How, with such primitive tools, did they manage to cut and extract over 2.5 million cubic meters of rock, an effort that would tax even our most powerful modern machinery, and to do so with a speed and efficiency that allowed the entire pyramid to be built in a span of just over 2 decades. Once a single 2.5-ton block was freed from the bedrock of the quarry, It presented the next great challenge: transportation. How do you move an object with the weight of a rhinoceros across the rough, uneven, and sandy terrain of the desert? The dead weight of the stone, its immense inertia, and the colossal friction between it and the ground would have been a formidable enemy. The prevailing and most widely accepted theory is that the blocks were placed on large wooden sledges to overcome the friction. It is believed that a small amount of water was poured onto the sand directly in front of the sledge's runners. A simple but ingenious trick that would have dramatically reduced the pulling force required. But this simple solution opens up a new vista of logistical questions. It would have required a vast army of workers, perhaps 20 or 30 men, for each and every block. It would have required the construction of immense and durable wooden sledges, a constant supply of rope, and a carefully prepared and maintained roadway between the quarry and the construction site. To maintain the relentless pace required to build the pyramid in 20 years, it is estimated that a new block had to be delivered to the base of the pyramid every 2 to 3 minutes, every hour of every day, for the entire duration of the project. And yet, the local limestone, for all its immense logistical challenge, was the simplest part of the puzzle. For the most sacred and structurally important chambers deep within the heart of the pyramid, a different and far more impressive material was used: a beautiful, hard, and pink-hued granite. This granite was not quarried on the Giza Plateau. Its source is at Aswan, a region in the far south of Egypt, over 800 kilometers or 500 miles up the Nile River. This presented a problem of a completely different order of magnitude. Granite is an igneous rock, immensely harder and more durable than the sedimentary limestone. The challenge of quarrying it with soft copper tools is almost beyond comprehension. And the granite blocks used in the Great Pyramid were not the standard 2.5-ton size. The massive beams that formed the roof of the king's chamber, the very heart of the pyramid, weigh between 50 and 80 tons apiece. These are objects with the weight of a modern battle tank. The stones have now been cut from the earth. Their almost unimaginable weight has been overcome by the ingenuity of the sledge, and they have been dragged across the sands of the desert and sailed for hundreds of kilometers up the great river Nile, to finally arrive at the foot of the Giza Plateau. A colossal, ever-growing mountain of precisely cut stone now sits at the construction site, a testament to a logistical and industrial effort that is without parallel in the ancient world. But now, the true and the greatest challenge of all begins. All of the work so far has been horizontal. The final and most profound question is the vertical one. How do you take these millions of multi-ton blocks and lift them one by one, some of them to a height of nearly 150 meters, the height of a modern 40-story skyscraper, into the open sky? How do you raise a mountain of stone into the air, and then place each block with the delicate precision of a watchmaker? The secret lies in one of the most fiercely debated and deeply mysterious engineering puzzles in all of human history: the ramp. The great mountain of stone now sits at the foot of the Giza Plateau, a colossal and ever-growing stockpile of precisely quarried blocks. The horizontal challenges of extraction and transportation have been met with a level of industrial and logistical genius that is without parallel in the ancient world. But now, the true battle begins, the great vertical problem that defines the very essence of the pyramid. Without the benefit of the pulley, without the power of the crane, and with no mechanical advantage beyond the simple, timeless physics of the lever and the inclined plane, the ancient Egyptians were faced with the challenge of pure, brute force elevation. They had to raise a mountain into the sky. The consensus among archaeologists and engineers is that this could only have been achieved in one way, with a ramp. And yet this simple, three-letter word, this seemingly obvious answer, is in fact a Pandora's box of profound and confounding new questions. The ramp is the missing machine, the great ghost in the pyramid's design. And in the search for this ghost, we find not a single clear answer, but a series of competing, ingenious, and deeply problematic theories. The most intuitive and widely imagined of these theories is that of the single, long, straight ramp. It is the image that we have seen in countless films and illustrations. A colossal causeway of earth, brick, and rubble, extending from a point far out in the desert and rising in a gentle, continuous slope to meet the current, ever-rising working level of the pyramid. This approach has the benefit of elegant simplicity. It would have provided a wide, straight, and unobstructed highway for the teams of workers to haul the multi-ton stone blocks up to the construction level. But when we begin to apply the cold, hard logic of mathematics to this idea, it begins to collapse under its own almost unimaginable weight. To maintain a manageable slope for the hauling teams, a gradient of no more than 8 to 10%, a ramp built to the final 146-meter peak of the Great Pyramid would have to have been over 1.5 miles long. The sheer volume of material required to construct such a ramp would have been colossal, by some estimates even greater than the volume of the pyramid itself. It would have been a second, even larger construction project, requiring its own immense workforce and its own complex logistics, and it presents us with a final, insurmountable archaeological problem. What happened to it? There is simply no evidence on the Giza Plateau for such a colossal structure. No trace of the millions of tons of material that would have been required to build it, and which would have then needed to be removed after the pyramid's completion. To solve this problem of material volume, a second major theory was proposed, the spiral or zigzag ramp. In this model, the ramp is not a separate external structure, but is built directly onto the faces of the pyramid itself, corkscrewing its way up the four sides of the monument as it grew in height. This solution is far more efficient. It requires dramatically less material than a long straight ramp, as it is supported by the body of the pyramid itself. But this elegant solution introduces its own set of critical and perhaps fatal flaws. The first is the problem of the corners. The Great Pyramid is renowned for the almost perfect precision of its four sharp straight corners, which form the very basis of its geometric power. How could the builders have maintained this incredible precision if the corners were constantly being obscured and varied by a massive, winding roadway? The second is the problem of logistics. A multi-ton stone block on a long wooden sledge is not an easy object to maneuver. How would the hauling teams have navigated the tight 90-degree turns at each corner of the pyramid, a process that would have been incredibly awkward, dangerous, and time-consuming? And perhaps the most significant flaw of all is the problem of surveying. The ancient Egyptians were master surveyors, but their tools were simple lines of sight. How could they have possibly maintained the overall geometric accuracy of the structure, ensuring it was rising towards a perfect single point if all four of their primary faces were constantly encumbered by the very ramp they were using to build it? It is these profound flaws in the external ramp theories that have led in recent decades to the development of a third, and in many ways, far more compelling and elegant solution, the theory of the internal ramp, championed by the French architect Jean-Pierre Houdin. This theory proposes a radical and brilliant idea. The pyramid was built in two phases. For the first, lower third of the structure, a short, straight external ramp was indeed used to lift the heaviest of the blocks. But once the pyramid had reached a certain height, this external ramp was dismantled, its materials recycled, and a new ramp was begun, one that spiraled its way up not on the outside of the pyramid, but on the inside, a few meters in from the outer casing. This internal, corkscrewing corridor would have allowed the builders to continue to haul the stones to the upper levels, but in a way that left the exterior faces and crucially the corners completely clear and unobstructed. allowing the surveyors to continue their work with perfect visibility. This ingenious theory solves at a single stroke all of the major problems of the external ramp theories. It requires no colossal missing ramp. It does not interfere with the geometry of the corners, and it provides a plausible explanation for how the work could have continued with speed and precision to the very top. It is a theory that is also supported by tantalizing, if not yet conclusive, physical evidence, including microgravimetric scans that have detected a strange, low-density, spiral-shaped anomaly within the body of the pyramid in the very location where such a ramp would be. The enduring mystery and the lack of a definitive answer have, over the years, given rise to a host of more unconventional and speculative ideas. Some researchers, struck by the ancient Egyptians' mastery of irrigation and their deep connection to the Nile, have proposed that water, not just muscle, may have played a role in the lifting of the stones. These water shaft theories imagine the construction of a sophisticated, internal system of water locks or canals. In this model, the stone blocks would have been floated on barges into a chamber at the base of the pyramid. The chamber would then be sealed, and water, pumped up from the Nile, would be used to raise the barge to the next level, a process that would be repeated, lock by lock, to the top. While these theories are fascinating and speak to a different kind of ingenuity, they present their own immense technical hurdles. The challenge of constructing a perfectly waterproof, multi-hundred-foot tall structure capable of withstanding the immense pressures of so much water, and the immense logistical challenge of pumping the millions of gallons of water required, are problems that, for most mainstream Egyptologists, make these theories a beautiful but highly improbable solution. Regardless of which of these grand ramp systems was used to bring the millions of blocks to the upper levels, the final few courses of the pyramid, the very peak of the structure, would have presented a new and unique set of challenges. As the pyramid neared its apex, the available working surface would have shrunk to a very small and incredibly precarious platform. A massive spiraling ramp, whether internal or external, would have become impractical for these final, delicate stages. It is here that the ancient Egyptians would have likely relied on their most fundamental and versatile tool, the lever. Small teams of highly skilled workers, using a complex and carefully coordinated system of large wooden levers, could have painstakingly and slowly rocked or walked the final few blocks up the last few meters. This would have been a slow, incredibly dangerous, and physically demanding process, but it would have provided the builders with a kind of fine millimeter-level control that would have been necessary for the final precise placement of the capstone, the pyramidion, that once crowned the very summit of the magnificent structure. The great ramp, therefore, whether it was a single colossal causeway that has now vanished, a winding external spiral that has left no trace, or a hidden and still undiscovered internal corridor, remains the most plausible, yet the most stubbornly unproven part of this great engineering puzzle. It is the ghost in this magnificent machine, the missing link in our understanding of how this mountain of stone was raised into the sky. But to focus only on the immense brute force challenge of the ramp is to miss the other, equally profound and perhaps even more impressive, half of the puzzle. It is not enough to simply get a 2.5-ton block of stone to the correct height. It must be placed with a precision that is almost perfect, fitted against its neighbors with joints so fine and so seamless that a single sheet of paper cannot be inserted between them. How did the ancient Egyptians, working on such a monumental scale, with millions of individual components, achieve this level of almost supernatural accuracy? This leads us away from the brute force of lifting, and into the subtle, quiet, and almost magical world of ancient surveying, of precise leveling, and of a mastery of measurement that seems for its time to be almost impossible. The great and enduring mystery of the ramp speaks to the immense physical and logistical challenge of the pyramid's construction. It is a story of brute force, of muscle, and of the raw power required to raise a mountain. But there is a second, and arguably even greater miracle encoded in the very stones of the Giza Plateau. It is the miracle of the pyramid's profound and almost supernatural precision. To focus only on the lifting of the stones is to miss the other half of the puzzle. It is one thing to raise a 2.5-ton block 100 meters into the air. It is another thing entirely to place it with a level of accuracy that is measured in fractions of a millimeter. This was not a feat of strength, but a feat of pure intellect. It speaks to a deep and sophisticated understanding of mathematics, of geometry, and of observational astronomy that seems for its time to be almost without precedent. This is the story of the quiet, patient, and methodical genius that guided the hands of the builders, the invisible software that ran the entire colossal operation. The very first act in this pursuit of perfection was the creation of a foundation that was itself a masterpiece of the surveyor's art. The Great Pyramid is built not on sand, but on a low rocky outcrop of the desert plateau. But this rock was not naturally flat. To support the immense weight of the structure without any risk of differential settling, the builders had to create a vast 13-acre footprint that was almost perfectly level. Modern surveys have shown that the entire base of the Great Pyramid, a surface area that could accommodate 10 professional football fields, deviates from a perfectly level plane by an average of just over half an inch. The most plausible method for how they achieved this stunning feat is a testament to their ability to use the simple, immutable laws of nature to their advantage. It is believed that the builders cut a grid of shallow, interconnected trenches into the bedrock across the entire site. They then filled this network of trenches with water, and the surface of this water, by the fundamental laws of physics, would have created a single, vast, and perfectly level reference plane. From this waterline, the surveyors could then measure down at hundreds of different points, guiding the work crews as they painstakingly chiseled and cut the surrounding bedrock down to a uniform and absolutely perfect elevation. With the foundation now a perfect horizontal plane, the next and most mystifying challenge was to orient this great square to the world. The Great Pyramid is not aligned to the magnetic north that a simple compass would show. It is aligned to true astronomical north, with a degree of accuracy that is simply astounding. Its four sides are aligned to the four cardinal directions, with an error of less than 3/60ths of a single degree. This level of precision was not surpassed in human construction until the late 19th century, with the advent of modern telescopic surveying equipment. The Egyptians, with no such technology, almost certainly achieved this by looking to the stars. The leading theory is that they used a method of stellar observation. A team of ancient priest astronomers would have constructed a perfectly level, circular observation wall. By sighting a single bright star as it rose in the east, and then as it set in the west, and marking these two positions on their wall, they could find the halfway point between them. A line drawn from the center of their circle through this halfway point would be a perfect and unwavering line pointing to true north. This celestial alignment, achieved with simple but effective instruments like the plumb bob and the sighting tool known as a bay, was the critical first line that was drawn in the sand, the primary axis upon which the entire colossal geometry of the pyramid would be built. Once this perfect north-south meridian was established, the builders had to lay out a perfect square, with 4 equal sides and 4 perfect 90-degree corners. Here too the genius lay in the elegant simplicity of their methods. It is highly likely that they created their right angles by using a technique that is still employed by surveyors and builders to this day, the use of the Pythagorean triplet. By taking a long continuous loop of rope with 12 knots tied at perfectly equal intervals, They could stretch it out around 3 pegs to form a triangle with sides of 3, 4, and 5 units in length. The angle opposite the longest side, the hypotenuse, will always be a perfect and unchangeable 90-degree angle. By using these simple rope stretchers as they were known, the ancient surveyors could lay out the vast 230-meter-long sides of the pyramid's base with an incredible degree of accuracy. The 4 sides of the Great Pyramid are equal in length to within a margin of error of only a few centimeters. There is also a deeper and more controversial mathematical property embedded in the pyramid's very dimensions. The ratio of the pyramid's original height to the perimeter of its base is almost exactly the same as the ratio of a circle's radius to its circumference, a relationship that yields the value of pi with an accuracy of over 99.9%. Whether this was a deliberate act of mathematical encoding or a simple coincidence of the elegant geometry they chose, remains one of the pyramid's most enduring and tantalizing secrets. To maintain this incredible precision as the pyramid rose course by course into the sky was a challenge of an even greater magnitude. The 4 vast faces of the pyramid had to rise from the base at a constant and unwavering angle of slope, 51.84 degrees, in order to meet at a single perfect point nearly 150 meters in the air. This was likely achieved through a combination of local checks and global overarching survey controls. For the individual blocks, the builders would have used a simple but effective system based on their unit of slope, the sikit. A skilled mason could use a simple wooden A-frame level with a plumb line to check that the face of each and every block was cut and laid at this precise, predetermined angle. To ensure the entire structure was not twisting or deviating as it grew, a master surveyor at the base would have maintained a constant watch, using long-distance lines of sight to guide the placement of the critical cornerstones for each new layer. These 4 corners were the anchors of the pyramid's geometry, and their precise placement on each course would have guided the thousands of other blocks that were laid between them. The pyramids that we see today, with their rough, stepped, and weathered faces, are only the raw structural cores of the original monuments. In their day, they would have been a sight of almost unimaginable splendor. Their 4 faces were once completely encased in a smooth, brilliant, and highly polished skin of fine white limestone, quarried from Tura, on the other side of the Nile. These casing stones, some of which still remain at the base of the pyramid, were dressed and fitted with a level of craftsmanship that is almost beyond belief. The joints between these multi-ton blocks are in many cases less than half a millimeter wide, so fine and so perfect that it is impossible to insert even a single human hair between them. This seamless skin would have transformed the pyramid from a stepped, man-made object into a perfect, pure, and gleaming white geometric form, a giant 4-sided crystal reflecting the brilliant Egyptian sun with a blinding intensity. This beautiful skin was not just for aesthetics. It also served a vital engineering purpose. The perfectly flat and smooth faces of the casing would have provided an ideal surface for the surveyors to constantly check and recheck the accuracy of their angles and alignments as the structure rose ever higher. This obsession with precision was not confined to the exterior of the monument. It extended deep into the very heart of the pyramid, into its mysterious and complex network of internal passages and chambers. The descending passage, a narrow, arrow-straight corridor that is only about a meter wide and a meter high, plunges down into the bedrock for a distance of over 100 meters. And yet it deviates from a perfectly straight line by less than 6 millimeters over its entire length. The floors of the king's and queen's chambers, the most sacred spaces within the structure, are leveled to a similar, almost perfect degree of accuracy as the pyramid's main base, and the great granite coffer that rests within the king's chamber the final intended resting place of the pharaoh, is itself a masterpiece of stoneworking. It is carved from a single solid block of extremely hard Aswan granite, with perfectly flat and parallel faces, and sharp, true 90-degree interior corners, a feat of craftsmanship that would be a profound challenge for even a modern stonemason, armed with diamond-tipped power tools. This profound and almost fanatical devotion to geometric perfection, this ability to impose a single, unified, and impossibly precise design upon a mountain of millions of individual stone blocks, reveals a level of intellectual, mathematical, and organizational sophistication that is profoundly humbling. The ancient Egyptians were not just masters of logistics and brute force labor. They were masters of measurement, of astronomy, and of a practical geometry that allowed them to achieve a level of accuracy that would not be seen again for millennia. But the question of this remarkable precision inevitably brings us back to the very stones themselves. We have marveled at their perfect placement, but what of their perfect creation, the seamlessly joined casing stones, the arrow-straight passages, and the perfectly flat walls of the great granite chambers were not created with simple, rough-hewn tools? How did a civilization that had not yet discovered iron or steel manage to cut and to shape and to polish the hardest stones on earth with a level of craftsmanship that seems to belong to a different age entirely? This leads us into the noisy, the dusty, and the deeply mysterious world of the ancient Egyptian stoneworker, and the lost and hotly debated techniques that they used to master their unforgiving material. The almost supernatural precision of the Great Pyramid, its perfect leveling, its celestial alignment, and its flawless geometry speaks to a profound intellectual mastery. But this grand abstract design had to be executed in the real world through the medium of stone. This brings us to a second, an equally profound paradox: the creation of objects of almost perfect craftsmanship, using a set of tools that were, by our modern standards, almost primitive. The ancient Egyptian stonemason had no steel, no diamond-tipped saws, no powered machinery. And yet the surfaces they created, the joints they fitted, and the forms they carved from the hardest rocks on earth are a testament to a level of skill and a depth of knowledge that can only be described as a form of lost science. The secret to their success, it seems, lay not in the sophistication of their tools, but in their intimate, hard-won, and generational understanding of their material, and in their complete mastery of techniques that relied upon immense patience, incredible skill, and the clever, relentless application of simple, abrasive friction. For the relatively soft non-mollitic limestone that makes up the vast majority of the pyramid's core and its original, brilliant white casing, the work, while still immense, was manageable with the tools at hand. In the great quarries of Giza and Tura, the initial separation of the blocks from the bedrock was likely achieved with a combination of copper chisels and wooden mallets, which were used to cut a series of deep, narrow channels to isolate a block on 3 of its sides. But the soft copper of these chisels would have blunted and deformed quickly against the stone. The true secret to the speed and efficiency of their work was almost certainly the use of a powerful abrasive. It is now widely believed that the primary cutting was done not by the sharp edge of a tool, but by the grinding action of quartz sand, a material that is abundant in the Egyptian desert and is significantly harder than the limestone. A simple, toothless copper saw, when used in conjunction with a constant slurry of water and this abrasive sand, is transformed into a powerful and effective cutting tool. The soft copper blade simply acts as a carrier, holding the hard quartz grains in the cut and drawing them back and forth, allowing the sand itself to do the slow, relentless work of grinding its way through the stone. This method, however, becomes almost impossibly difficult when applied to the far harder and more formidable material that was reserved for the pyramid's most sacred inner chambers, the Aswan granite. Granite is a crystalline igneous rock, many times harder and more durable than limestone. It is in fact harder than the copper of the Egyptian tools themselves. To attempt to cut it with a simple copper chisel would be like trying to cut a steel beam with a blade made of wood. To shape the colossal 80-ton blocks of granite that were used to build the king's chamber, the Egyptians had to turn to a different and far more brutal technique. This was the work of pure percussion. The primary tool for shaping these granite behemoths was the dolerite pounder. Dolerite is an exceptionally hard, dense, igneous rock, and the Egyptians would shape it into large, heavy, handheld balls. For countless hours in the searing heat of the Aswan quarries, teams of workers would have painstakingly and methodically hammered at the surface of the granite with these stone pounders, slowly and laboriously pulverizing the crystalline structure of the rock, chipping away at it gram by gram, until the colossal block was battered into the desired, roughly rectangular shape. But this percussive shaping could only create a rough, pockmarked surface. The great granite beams and the walls of the king's chamber are by contrast remarkably flat and smooth. To achieve this, a different and far more sophisticated technique must have been employed. Modern analysis of the tool marks left on these granite surfaces, particularly the faint, perfectly parallel striations that are visible under specific lighting, have led many Egyptologists to a stunning conclusion. It is believed that the Egyptians used immense, large-scale saws to slice the faces of these granite blocks. These would have been long, thick, and toothless blades of copper or bronze, perhaps several meters in length, and they would have been operated by a team of workers pulling in a rhythmic two-man motion. Just as with the limestone, the saw itself would not have done the cutting. The secret would have been the abrasive slurry, a constant stream of wet quartz sand, or perhaps an even harder abrasive like emery or corundum, which was known to the ancient Egyptians and is almost as hard as diamond. The unimaginable screech of this process, the slow grinding roar of a soft metal blade dragging a slurry of hard sand across a slab of granite, day after day, week after week, is the lost sound of how these perfect flat plains were likely created. Perhaps the most baffling puzzle of all is the creation of the great granite coffer that sits in the heart of the king's chamber. This sarcophagus is not built from separate slabs. It was carved and hollowed out from a single solid block of granite. The perfectly flat exterior is one challenge, but the sharp 90-degree interior corners and the smooth hollowed-out basin represent a feat of craftsmanship that is simply staggering. The primary evidence for how this was achieved comes from other Egyptian sites, where granite artifacts have been found bearing the unmistakable marks of a tubular drill. It is now believed that the Egyptians used a hollow copper tube, perhaps mounted on a weighted, rotating shaft that could be turned by a large bow-like mechanism. With the addition of a hard abrasive, this rotating copper tube would not cut, but would grind a circular channel deep into the granite. By drilling a series of these overlapping circular cores out of the center of the block, the workers could then break out the remaining webs of stone with levers, a slow but effective method for removing the bulk of the interior material from this incredibly hard stone. The immense and continuous down pressure and the high rotational speed that would have been required to make this work remain a subject of intense academic and experimental debate. Once the stones were cut and shaped, they underwent a final, painstaking process of finishing and polishing. The original white limestone casing stones, in particular, were polished to a smooth, almost mirror-like sheen that would have gleamed in the desert sun. This was a slow, multi-stage, and labor-intensive process of pure abrasion. The masons would have used a series of handheld rubbing stones, of various shapes and sizes, to grind the surface of the stone to a perfectly flat plane. They would have begun with a coarse abrasive slurry, such as quartz sand, to remove the major imperfections and tool marks. They would then have moved to a series of progressively finer and finer abrasives, perhaps a fine desert silt, and then a polishing paste made from finely ground powders of minerals like feldspar or calcite. This process of rubbing and polishing the surface for countless hours with a delicate and practiced touch is what would have produced the final, gleaming, and almost seamlessly joined skin of the completed monument. This colossal quarry-to-pyramid industrial operation, which lasted for more than 2 decades, required a workforce of a scale that the world had never before seen. The long-held myth, popularized by Hollywood films, is that the pyramids were built by a vast army of slaves toiling under the whip of a tyrannical pharaoh. But every piece of modern archaeological evidence points to a completely different and far more impressive reality. The discovery of a vast planned city for the workers just to the south of the Giza Plateau has revolutionized our understanding. Here we have found the remains of large dormitory-like barracks, of immense bakeries capable of producing thousands of loaves of bread each day, and of facilities for salting and drying fish. All evidence of a well-organized and, crucially, a well-fed and well-cared-for workforce. The associated cemetery shows that these workers, when they died, were buried with honor in the shadow of the great monuments they were creating, and their skeletons show that they received sophisticated medical care for the broken bones and the injuries that were an inevitable part of this dangerous work. The pyramids, it now seems certain, were built not by slaves, but by a skilled, respected, and dedicated workforce of Egyptian citizens, perhaps working as a form of national service or taxation, all united in a single, monumental, and generational project. The secrets of the ancient Egyptian stonemason, therefore, seem to lie not in some lost high-tech machine, but in a profound and intimate mastery of simple, powerful principles, a mastery that was amplified by an almost unimaginable and sustained investment of time, of skilled labor, and of a brilliant logistical organization. The perfect polished surfaces and the seamless hairline joints are a quiet and enduring testament to a workforce that was not just immensely strong, but was also incredibly skilled, highly motivated, and exceptionally well managed. But once these millions of perfectly crafted stones were finally brought to the foot of the ever-rising pyramid, they had to be integrated into a complex, a mysterious, and a deeply symbolic internal architecture. We now turn our gaze away from the great exterior of the pyramid and prepare to venture deep into its heart. What was the true purpose of the labyrinth of hidden passages, of the strange, empty, and perfectly crafted chambers, and of the mysterious, star-aligned shafts that lie buried deep within this great silent mountain of stone? The great mountain of stone, for all its colossal and overwhelming external presence, was merely a shell. It was a fortress, a massive and impenetrable suit of armor that was designed and built for a single purpose: to protect the small, sacred, and incredibly complex universe that lies hidden within its heart. The interior of the Great Pyramid is not a simple tomb. It is a three-dimensional architectural rendering of the ancient Egyptian journey into the afterlife. It is a labyrinth of impossibly straight passages, of perfectly crafted but strangely empty chambers, and of mysterious, star-aligned shafts, all of which were designed and constructed with the very same, almost fanatical precision as the pyramid's exterior. This inner world is a masterpiece of structural engineering, a complex machine of stone designed to function for an eternity, to protect the body of a divine king, and to guide his soul on its final journey to the stars. To understand the pyramid, we must now enter it. Our journey inside begins not at the original intended entrance, a stone doorway that was once hidden and perfectly sealed behind the smooth white casing stones, but through a crude and violent wound that was punched into the pyramid's northern face. This is the robber's tunnel, a passage that was hacked into the monument in the 9th century AD by the treasure-hunting expedition of the Caliph al-Ma'mun, driven by the persistent legends of the immense riches that were said to be hidden within. His men, with no knowledge of the true entrance's location, simply began to chisel their way through the solid limestone core. For weeks they toiled, their crude tunnel boring aimlessly into the immense mass of the pyramid, until by sheer chance the vibrations of their work dislodged a stone in a nearby passage, and its crashing echo allowed them to finally locate and break into the pyramid's original and long silent internal network. From the point of this forced entry, the first of the pyramid's original passages is revealed, the descending passage. This is a long claustrophobic corridor, just over a meter high and a meter wide, that plunges down into the earth at a steep and unwavering angle of 26 degrees. The precision of this passage is the first great marvel of the pyramid's interior. Over its entire 100-meter length, it deviates from a perfectly straight line by only a few millimeters. It is an arrow straight cut, driven not just through the built masonry of the pyramid, but deep into the solid, living bedrock of the Giza Plateau itself. This long downward journey culminates in a strange, unfinished, and roughly hewn room known as the subterranean chamber. It is a place of profound mystery. Its floor is uneven, its walls are jagged, and a deep, enigmatic pit is cut into its floor. Was this the pyramid's original intended burial chamber, abandoned for some unknown reason in favor of a new plan? Or did it serve some other deeper and symbolic purpose in the complex cosmology of the Egyptian afterlife? It is the first great unanswered question of the pyramid's inner world. Traveling back up the descending passage, one comes to a point in the ceiling where a new path was ingeniously hidden. The entrance to the ascending passage was originally blocked by a series of 3 immense and almost immovable plugs of solid Aswan granite. These plugs, which were likely slid down into position after the pharaoh's burial, were the primary security device of the lower pyramid, a permanent and formidable deadbolt. It was these plugs that Al-Mamun's men were forced to painstakingly and laboriously dig around, cutting a new crude passage through the softer limestone beside them. Once past this ancient security gate, the ascending passage presents a new and arduous journey. It rises at the very same steep 26-degree angle as the passage below it, but this time the journey is upwards. A difficult and slippery climb up a narrow, enclosed, and steeply inclined corridor that leads ever deeper and higher into the heart of the great mountain of stone. At the junction where the ascending passage levels out, the path of the pyramid splits. A narrow horizontal corridor continues straight ahead, leading to the second of the pyramid's great chambers. This room, due to an early misinterpretation by Arab explorers, has been known for centuries as the Queen's Chamber. It is a beautiful and perfectly proportioned room, built entirely of fine white limestone and crowned with a magnificent gabled roof. In its eastern wall there is a tall, corbelled niche, its purpose unknown. But the greatest mystery of this chamber lies in its north and south walls. From each of these walls a small, square shaft, only about 20 centimeters wide, extends horizontally for a few meters and then begins to climb up into the immense, unknown mass of the pyramid. For centuries their existence was a complete mystery. Then, in the 1990s, a small robotic rover named Upwat was sent to explore them. After a long and difficult journey, the robot's camera revealed a stunning sight. The northern shaft was blocked by a small stone slab, a mysterious door which was adorned with 2 enigmatic copper handles. A later exploration of the southern shaft found a similar door. These are not vents, and they are not passages. They are a profound architectural and archaeological puzzle that remains, to this day, completely unsolved. Returning to the main path, The visitor now enters the single most breathtaking and architecturally magnificent space in the entire pyramid, the Grand Gallery. After the claustrophobic confinement of the passages, the gallery explodes upwards, a colossal, soaring, and steeply inclined corridor that is over 46 meters long and over 8.5 meters high. Its walls are a masterpiece of pristine corbelled masonry, with each of the 7 courses of stone cantilevering slightly out over the one below it, creating a magnificent inverted staircase that narrows as it reaches the ceiling. This stunning architectural feature is not just for beauty. It dramatically reduces the span of the roof and helps to manage the immense compressive forces of the masonry above. Along the base of its walls, a series of mysterious ramps and grooves have been cut, their purpose the subject of intense debate. Were they part of a complex pulley or counterweight system used to haul the great granite plugs into place in the antechamber above? Or did they serve some other, now lost ritualistic function? The Grand Gallery is a true cathedral of stone, a space of immense power and profound mystery. At the very top of this great ascending gallery, after passing through a small antechamber that was once protected by a series of sliding portcullis-like granite slabs, one finally arrives at the ultimate destination, the very heart of the pyramid, the king's chamber. The transition is stark and dramatic. The fine white limestone of the gallery gives way to the deep reddish-pink hue of solid Aswan granite. The entire chamber, a perfect rectangular box, is constructed from these colossal and perfectly fitted granite blocks. The atmosphere within is heavy, silent, and deeply resonant. The air is cool and still. The only object within this stark and magnificent room is the final and most poignant artifact of all, the pharaoh's sarcophagus. It is a large rectangular coffin, carved from a single block of dark chocolate-colored granite. It is undecorated. Its lid has long since vanished, and it has been slightly damaged by the ancient tomb robbers who were the first to enter this sacred space. It is a simple, empty, and powerful testament to the original purpose of this entire colossal mountain of stone. Yet even here, in the very heart of the monument, the ancient engineers had one more final and brilliant secret: the flat roof of the king's chamber, which is formed by 9 massive 80-ton granite beams, must support the weight of over 70 meters of the pyramid's core, a load of over 1,000,000 tons. To prevent this immense weight from crushing the chamber flat, the builders constructed a series of 5 low-roofed and roughly finished chambers directly on top of one another, in the space immediately above the chamber's ceiling. These are the relieving chambers, a hidden and profoundly ingenious structural system. These stacked open spaces, separated by massive granite beams, act as a massive arch, collecting the immense downward pressing forces from the pyramid's apex and deflecting them away from the fragile flat ceiling of the chamber below, and safely into the immense solid mass of the surrounding masonry. And from this final chamber, 2 more small shafts, similar to those in the Queen's chamber, extend, but these shafts were not sealed. They were open to the outside faces of the pyramid, and their angles were precisely calculated to align with the circumpolar stars in the northern sky, and with the constellation of Orion in the south, the celestial embodiment of the god Osiris, giving the soul of the departed king a direct, symbolic pathway to his eternal stellar destiny. This complex and deeply symbolic, 3-dimensional labyrinth of perfectly crafted passages and chambers, a true marvel of both structural and spiritual engineering, forms the complete and hidden universe that is concealed within the Great Pyramid. It is, in its entirety, a great and silent machine for the afterlife, a fortress of stone that was designed with an almost unimaginable level of care and precision to protect the physical body of the pharaoh, and to guide his spiritual essence on its final celestial journey. But a fortress, no matter how strong, is only as good as the army that builds it. We have spoken of the great workforce as a collection of skilled and respected citizens. But who exactly were they? How was this colossal, city-sized army, this force of tens of thousands of craftsmen, of laborers, of surveyors, of scribes, and of managers, actually organized? How were they housed? How were they fed? And how were they managed, day after day, for over 2 decades, to create a single, unified project of such breathtaking and almost incomprehensible scale and precision? This leads us away from the great stones themselves and into the remarkable and only recently discovered world of the people who built them. A monument of the scale and precision of the Great Pyramid is not just a feat of engineering, it is, first and foremost, a feat of human organization. The colossal structure is a physical testament to a now lost machine. A machine that was not made of gears and levers, but of tens of thousands of human beings, all working in perfect coordinated synchrony for a period of more than 2 decades. The true genius of the pyramid builders may not have been in their ramps or their tools, but in their profound and unprecedented mastery of project management. To quarry, to transport, to lift, and to place a multi-ton stone block every 3 minutes requires a level of logistical and managerial sophistication that is simply staggering. To understand how the pyramid was built, we must therefore look away from the monument itself and turn our gaze towards the remarkable and only recently discovered world of the people who built it, and the complex, city-sized organism that was created to support them. For centuries, the daily life of the pyramid builders was a complete mystery, a void in the historical record that was filled with speculation and myth. But in the late 20th century, a series of stunning archaeological discoveries led by the Egyptologist Mark Lehner finally located and began to excavate the most important site on the entire Giza Plateau, next to the pyramids themselves, the lost city of the workers. Buried beneath the sands just to the south of the great monuments, a vast and highly organized settlement was uncovered, a sprawling urban center that was, for a time, one of the largest and most complex cities on Earth. This was not a slave camp. It was a meticulously planned city, with paved streets, administrative buildings, and distinct zones for different classes of workers. The most striking feature of the city is a series of immense gallery-like barracks, long dorm-style buildings that could have housed, on a rotating basis, the thousands of conscripted laborers who provided the raw muscle for the project. In a separate, more established residential district, archaeologists have found the remains of more permanent family-style homes, the residences of the highly skilled permanent workforce, the master craftsmen, the artisans, the scribes, and the high-level overseers who were the brains of the entire operation. The sheer logistical challenge of feeding this immense, city-sized workforce day after day for 20 years would have been a monumental undertaking in its own right. The discoveries within this lost city have revealed the secrets of this colossal catering operation. Archaeologists have unearthed the remains of vast, industrial-scale bakeries with rows upon rows of heavy ceramic bread pots, capable of producing thousands of loaves of bread and brewing thousands of gallons of nutritious beer, which was a staple of the ancient Egyptian diet. They have also uncovered immense quantities of animal bones. A detailed analysis of these bones tells a remarkable story. The workers were not being fed scraps or leftovers. The vast majority of the bones are from prime-aged cattle, with a smaller proportion of sheep and goats. These were not the tough old animals at the end of their working lives. This was high-quality, protein-rich food, the fuel required for the hard physical labor of building a mountain. This diet, far richer than that of the average Egyptian farmer, is one of the single most powerful pieces of evidence that these workers were a valued and well cared for state asset. This vast workforce was not a chaotic mob, but a highly structured and organized army. From the faint traces of graffiti, written in red ochre by the workers themselves on the hidden faces of the stone blocks, we can begin to reconstruct their complex social organization. The entire workforce was divided into two large divisions, perhaps representing Upper and Lower Egypt. Each of these divisions was then subdivided into smaller groups, known as files in the ancient Greek, which were in turn comprised of around 1,000 men. These files were then broken down into the smallest and most fundamental working unit, the gang, a team of perhaps 20 to 40 men. These gangs often had their own distinct and sometimes boisterous identities. From the graffiti, we know the names of some of these teams, names that have a wonderfully human and timeless ring to them: the Friends of Khufu Gang, or the even more famous, the Drunkards of Menkaure Gang. These are the faint, human voices that have survived for 4.5 millennia, speaking to a sense of camaraderie, of team spirit, and of a competitive pride in their monumental work. While the gangs of conscripted laborers provided the immense muscle power required to haul the millions of stone blocks, the project would have been impossible without the smaller but absolutely essential population of permanent, highly skilled craftsmen. In the more established residential areas of the workers' city, we see the evidence of the lives of these master artisans and the overseers who managed the project. These were the surveyors, who performed the celestial alignments and maintained the pyramid's perfect geometry. They were the master stonemasons, who carved the granite coffer with such precision. They were the metallurgists who were responsible for casting and constantly resharpening the thousands of soft copper chisels that were blunted and worn out every single day. And they were the scribes and the managers who were the true masters of the project, the men who kept the meticulous records, who calculated the supply needs, who scheduled the work crews, and who were responsible for the day-to-day running of this colossal and incredibly complex human machine. These were the full-time professional core of the operation, the keepers of the institutional knowledge that was passed down from one generation of builders to the next. The work on the Giza Plateau was relentlessly demanding and incredibly dangerous. An examination of the skeletons that have been recovered from the workers' cemetery, located on a hillside just above the city, provides a stark and moving testament to the physical price that was paid to build these monuments. The bones of these ancient builders show a high incidence of the kinds of traumatic injuries that one would expect from a life of heavy industrial labor. There are numerous examples of crushed fingers and hands, of legs that were broken by falling stones, and of severe degenerative arthritis in the lower backs and knees, a direct result of a lifetime spent hauling immense loads. But these same skeletons tell another, even more profound story. They show clear and undeniable evidence of expert medical care. Bones are often perfectly set and show signs of having healed cleanly. Skulls show evidence of primitive but successful brain surgery. Amputations were performed with a clean surgical precision. This is perhaps the most powerful evidence of all, that these were not slaves. They were valued members of a society that provided them with the best available medical treatment for their work-related injuries, a level of care that would have been unheard of for a disposable workforce. Taken together, this wealth of archaeological evidence, from the high-quality diet, to the organized and permanent housing, to the honorable burials, and the sophisticated medical care, has completely and definitively overturned the old romantic myth of a vast army of slaves toiling under the lash. The modern scholarly consensus is now almost unanimous. The Great Pyramids of Giza were built by a dedicated and well-compensated workforce of native Egyptian citizens. The bulk of the manual labor was likely provided by a rotating levy of conscripted farmers, who would work on the project for a period of a few months, perhaps during the annual inundation of the Nile, when their fields were flooded and they were unable to work, as a form of national service or taxation that was known as the corvée. This was not an act of brutal oppression. It was, in all likelihood, the great unifying national project of its age, an immense undertaking that brought together the entire country, from the humble farmer to the most skilled artisan, in the shared and sacred task of building an eternal home for their divine king. The remarkable and only recently discovered lost city of the pyramid builders gives us a profound and deeply human insight into the living, breathing, and incredibly sophisticated engine that was created to construct these great monuments. The pyramids we now understand are a testament not only to an almost unbelievable feat of engineering, but also to an equally unbelievable feat of logistical and managerial genius. But with our understanding of the workforce now clear, we must turn our attention back to the great monument itself. There is one great and gleaming piece of this ancient puzzle that is still missing from our story. What of the very peak of the pyramid, the final crowning stone that once sat upon its summit? And what of the brilliant, the white, and the perfectly polished casing of Tura limestone that once covered the entire structure? A magnificent and seamless skin that has now almost entirely vanished from the world. This leads us to the final story of the pyramid's construction, the story of its original and now lost breathtaking appearance. The great tan-colored stepped monuments that we see on the Giza Plateau today are a ghost of a memory. They are the rough, weathered, and powerful skeletons of their former selves, their true and original glory stripped away by the slow, relentless passage of millennia. To stand before the Great Pyramid today is to see a magnificent ruin, but a ruin nonetheless. To truly comprehend the vision of its ancient builders and the profound impact it would have had on the ancient world, we must attempt to look past the damage of the centuries. We must, in our imagination, try to see it as the ancient Egyptians saw it, not as a rough and jagged mountain of stacked blocks, but as a single, pure, and seamless geometric form, a colossal four-sided crystal of brilliant, polished white, a structure that was not designed to blend in with the desert landscape, but to stand in radiant and defiant contrast to it, a true and literal beacon of light. This brilliant white skin was created from a material that was prized above all others by the ancient Egyptian builders, the fine pure limestone of Tura, while the 2 million core blocks of the pyramid were quarried from the rough, fossil-rich limestone of the Giza Plateau itself. The 144,000 casing stones that would form its outer layer were sourced from a different and far more special location. The Tura quarries, located on the eastern bank of the Nile, miles away from Giza, yielded a limestone that was renowned for its beautiful, uniform, and brilliant white color, and for its fine, dense grain, which allowed it to be carved with incredible precision and polished to a magnificent, almost marble-like sheen. The quarrying of this stone would have been an even more meticulous and painstaking process than the quarrying of the core blocks. Each of the multi-ton casing stones was a finishing piece, a jewel to be set in the final visible face of the monument, and it would have been extracted and shaped with an almost religious level of care. The craftsmanship that was employed to fit these colossal white jewels together into a single seamless skin is perhaps the most stunning and inexplicable achievement in all of ancient stonemasonry. Each of the 144,000 casing stones was not a simple, rectangular block. Each one had to be cut as a complex and perfect geometric shape, with its top and bottom faces parallel, but its great outer face cut at the precise, unwavering 51.84 degree angle required to form the pyramid's perfect slope, and these multi-ton angled blocks were then fitted together across a vast 21-acre sloping surface with a level of precision that is almost beyond belief. The joints between the stones are, in the few places where they still exist, often less than 1/50th of an inch wide, a gap so fine that it is impossible to insert the blade of a modern penknife between them. This was achieved with no modern measuring equipment, likely through a slow and painstaking process of trial and error, of rubbing two massive stones together with a fine abrasive paste until they met in a perfect airtight seal. The final visual effect of this colossal and perfectly crafted skin would have been a sight of almost supernatural splendor, with its millions of rough internal core blocks completely hidden from view. The pyramid would not have appeared to be a structure that was built at all. It would have appeared as if it had been carved, fully formed from a single, solid piece of brilliant white stone. This vast, unbroken, and highly polished limestone surface would have acted as a colossal, multifaceted mirror, reflecting the brilliant, unfiltered light of the Egyptian sun with a blinding intensity. From a distance, it would have been a beacon, a landmark visible for dozens of miles across the desert and the green expanse of the Nile Valley. It would have been a pure abstract and geometric form, a perfect gleaming mountain of light that would have seemed to the ancient Egyptians to be not a thing of this world, but a physical manifestation on earth of the descending, life-giving rays of the sun god Re. At the very peak of this gleaming white mountain, the single most important stone of the entire structure would have been placed, the pyramid, or the capstone. This was a single, perfectly shaped, miniature pyramid that formed the apex of the monument, and was the final piece of the great puzzle to be put in place. While the capstone of the Great Pyramid itself has been lost to history for millennia, we know from historical texts and from the few smaller pyramidia that have survived from other monuments that these were the most sacred and most precious objects in the entire structure. They were often carved from a single block of the finest granite, and then it is widely believed they were cased in a layer of a precious shining metal. Some texts suggest this was pure gold, while others suggest it was electrum, a natural and highly prized alloy of gold and silver. This golden or electrum-cased peak would have been the first part of the monument to catch the rays of the rising sun each morning, and the very last to be illuminated as the sun set each evening, appearing to the people below like a brilliant, divine, and eternal star, hovering in the sky at the very summit of the man-made world. For over 3,500 years, the Great Pyramid stood in this state of pristine and brilliant perfection, but its magnificent skin, the very source of its beauty, was also the source of its eventual ruin. In the year 1303 AD, a massive earthquake struck the region of Cairo. While the immense and stable core of the pyramid was largely unharmed, the powerful tremors shattered and loosened a great number of the precious white casing stones, sending them tumbling down the sides of the monument. In the centuries that followed, as the new and growing city of Cairo began to flourish, the rulers and builders of this new capital saw the fallen pyramid not as a monument to be preserved, but as a convenient and high-quality quarry. For hundreds of years, the fallen casing stones and then the ones that were still attached to the pyramid's face were systematically stripped away, carted off, and recycled into the construction of the great mosques, the towering minarets, and the formidable fortress walls of medieval Cairo. It was a slow and tragic act of deconstruction, the divine and ancient mountain being carefully dismantled, piece by precious piece, to build a new human and worldly city. The complete and almost total removal of this magnificent skin is one of the great architectural losses of human history. Today, almost all of the 144,000 casing stones are gone, but a few precious remnants still survive, clinging to the base of the monument, protected by the centuries of accumulated sand and debris. In these few surviving sections, one can still see and touch the almost unbelievable quality of the original work, the impossibly fine joints, the perfectly flat surfaces, and the sheer stark beauty of the pure white Tura limestone. An even more impressive and tantalizing glimpse of the pyramid's former glory can be seen on the neighboring pyramid of Khafre, the second largest on the Giza Plateau. Here, a significant cap of its original casing stones still clings to the very peak of the monument. A ghostly white triangle against the blue sky. A powerful and poignant reminder of the breathtaking splendor that we have lost. This lost gleaming skin of the pyramid, and the brilliant golden capstone that once crowned its summit, are a powerful and almost heartbreaking reminder that the great monuments we see today are but a shadow, a weathered and rugged skeleton of a far more magnificent, a more perfect, and a more otherworldly original. The tragic but practical destruction of this beautiful outer layer has, however, had one ironic and unintended consequence. It has exposed the great structural core of the pyramid to our view, allowing us to see and to study the immense 2.5-ton building blocks that form its heart, and to ponder the great mysteries of how they were lifted. But the Great Pyramid of Khufu, for all its colossal size, does not stand alone. It is the vast and silent centerpiece of a far larger, a more complex, and a deeply symbolic architectural and spiritual landscape. What, then, was the purpose of the other great structures that surround it? What secrets are held by the enigmatic and silent, half-human, half-animal watcher of the plateau, the Great Sphinx? And what was the true function of the mysterious and long-abandoned temples that lie in ruins at the foot of these great silent mountains of stone? The Great Pyramid of Khufu, for all of its breathtaking and singular glory, was never intended to stand alone. It is the colossal and central gear in a far larger, more complex, and more intricate machine. The entire Giza Plateau was conceived and constructed as a single, unified, and deeply symbolic landscape, a vast and permanent architectural model of the ancient Egyptian cosmos, a necropolis that was designed not just to house the dead, but to actively and perpetually facilitate the pharaoh's journey from his mortal existence to his divine and stellar afterlife. To understand the Great Pyramid, therefore, one must understand its context. One must look beyond its gleaming white slopes and see the family of other great monuments, the silent, enigmatic guardian, and the ruined but once vibrant temples that surround it. These are not separate, unrelated structures. They are the integral and interconnected components of a single, great, and stone-built funerary machine. At the heart of this landscape lies a dynastic mountain range of stone, a statement of power and lineage built by 3 successive generations of a single, powerful family. The Great Pyramid of Khufu is the patriarch of this family, the largest and the first. To its southwest stands the second great monument, the Pyramid of Khafre, Khufu's son. While it is in fact a few meters shorter than his father's pyramid, it was cleverly and deliberately constructed on a slightly higher piece of the plateau, a trick of perspective that gives it the illusion of being the taller of the two. The Pyramid of Khafre is a monument of profound importance to our understanding, for it is the only one of the Giza pyramids that still retains a portion of its original polished white limestone casing, a ghostly and beautiful cap that clings to its very peak, providing us with our single greatest clue to the original breathtaking appearance of all 3. And beside it stands the third and final of the Great Pyramids, the Pyramid of Menkaure, Khafre's son and successor. It is dramatically smaller than the other 2. Perhaps a sign of a decline in the immense resources that were available to these kings. But it is unique in its own right, for its lower 16 courses were karst not in the fine white limestone of Tura, but in the immensely hard and far more expensive red granite from Aswan, a project of immense ambition that was, for reasons that are still debated, left mysteriously unfinished, guarding this great dynastic necropolis. To the east of the pyramids lies the most enigmatic and iconic statue in the entire world, the Great Sphinx. This colossal monument, the largest monolithic statue on the planet, is a creature of profound and silent mystery. It was not built in the conventional sense. It was carved fully formed from a single massive outcrop of the living limestone bedrock of the Giza Plateau itself. It is a composite, mythological being, with the powerful, reclining body of a lion, a timeless symbol of royalty and power, and the head of a human king, a face that most Egyptologists believe is a portrait of the pharaoh Khafre himself, the builder of the second pyramid. The Sphinx was the great guardian of the sacred precinct, a symbol of the king's divine power, silently watching the eastern horizon and the rising sun for all of eternity. But its true original name, its precise ritualistic purpose, and even its exact age remain the subjects of a fierce and ongoing debate, a deep and enduring mystery that only adds to its powerful and almost hypnotic allure. The great funerary ritual, the final journey of the deceased king, did not begin on the high desert plateau, but down below it on the fertile green edge of the Nile's annual floodplain. Here, at the edge of the world of the living, the great valley temples were constructed. These were the grand ceremonial gateways to the entire Giza complex. The most well-preserved of these is the Valley Temple of Khafre, a masterpiece of stark, minimalist, and megalithic architecture. It is a simple, square building, constructed from colossal 100-ton limestone core blocks, and then completely cased both inside and out, in massive, perfectly fitted blocks of polished red Aswan granite. It was to this temple that the body of the deceased pharaoh, having made its final journey by boat down the river Nile, was brought. It was within the dark, cool, and silent halls of this temple that the complex, secret, and 70-day-long rituals of mummification were likely performed, the sacred process of preserving the king's physical form for its eternal life in the world beyond. From this gateway on the floodplain, a long, enclosed, and ceremonial roadway, known as the causeway, led on a gently rising slope up to the high desert plateau and the foot of the pyramid itself. These were not simple, open-air roads. The surviving remnants of these causeways show that they were impressive architectural structures in their own right. They were high-walled, paved, and almost certainly roofed, creating a long, dark, and enclosed corridor. The inner walls of this corridor were once covered, from floor to ceiling, in thousands of square meters of beautiful and finely carved painted reliefs. These reliefs would have depicted scenes from the life of the king, his triumphs in battle, his religious duties, and his divine connection to the gods. The funeral procession, as it moved slowly up this long enclosed gallery, would have been a profound, symbolic, and liminal journey, a physical transition from the lower, fertile, and sunlit world of the living to the high, arid, and silent, eternal world of the dead. At the very end of this long ceremonial journey, at the center of a vast paved courtyard at the foot of the pyramid's eastern face, stood the most important building for the king's eternal life, the mortuary temple. These temples, now largely in ruins, were the true vibrant and functioning heart of the pyramid complex for centuries after the king's death. They were not tombs. They were cult centers, divine chapels where a dedicated and endowed priesthood would perform the daily rituals and present the continuous offerings of food, of drink, and of incense that were required to sustain the pharaoh's spiritual essence, his ka for all of eternity. The typical layout of these temples included an entrance hall, a large, open-air, pillared courtyard for public ceremonies, a series of magazines and storage chambers for the offerings, and at the very back, against the face of the pyramid, a sacred inner sanctuary. This sanctuary would have contained a false door, a beautifully carved stone replica of a doorway, which was believed to be a symbolic portal through which the spirit of the deceased king could pass from his tomb inside the pyramid to partake in the offerings that were left for him in the world of the living. The divine king, however, was not expected to journey into the afterlife alone. The Great Pyramids are surrounded by a vast and beautifully ordered city of the dead, a necropolis for the king's family and his most trusted followers. Clustered close to the main pyramid are a series of much smaller satellite pyramids, popularly known as the Queen's Pyramids. These were the eternal resting places for the pharaoh's principal wives, and, in some cases, his mother, and laid out in neat, almost suburban grid-like streets around the three Great Pyramids are hundreds of smaller, rectangular, and flat-topped tombs, known as mastabas. These were the tombs of the other members of the royal family, the high-ranking viziers, the scribes, the architects, and the high priests who had served the king in life. The Giza Plateau was, in its entirety, a perfect and permanent recreation of the royal court, a society of stone that was designed to ensure that the king would be surrounded in death by the very same family and the very same loyal administrators who had surrounded him in life. This vast, interconnected, and deeply symbolic landscape reveals with a stunning clarity that the pyramids were never just isolated tombs. They were the powerful and permanent central engines in a great and complex machine that was designed to ensure the eternal life of a divine king, and by extension, to guarantee the continued stability and prosperity of the entire Egyptian cosmos. Every single element of this sacred plateau, from the silent, watchful gaze of the Sphinx to the ritualistic purity of the temples and the loyal court of the mastabas, played a crucial and interconnected role in this great stone-built and eternal ritual. But there was one final and incredibly precious set of artifacts that was also a vital part of this great machine. A set of beautiful objects that were not meant to be a part of the monument itself, but were a critical part of the king's final funerary rites, and were then carefully buried beside it, to accompany him on their own parallel journey into eternity. What secrets, then, can be learned from the magnificent, the full-sized, and the almost perfectly preserved ceremonial boats of the pharaoh, which lay hidden for more than 45 centuries in a series of deep and hermetically sealed stone pits at the very foot of the Great Pyramid? The Giza Plateau, for all of its meticulous and symbolic planning, still held deep secrets, treasures that were not lost to the sands of time, but were deliberately and perfectly hidden from it. These were not treasures of gold or of jewels, but of a far more profound and revealing kind. They were objects that were a central and vital part of the great funerary machine, but which were never intended to be seen by mortal eyes again. They were interred in their own custom-built tombs of stone, buried and sealed at the same time as the Great Pyramid itself, destined to accompany the pharaoh on his journey into eternity. The story of their discovery is a moment of pure archaeological wonder, a sudden and unexpected window that opened for a brief moment directly into the lost world of the Fourth Dynasty. In the year 1954, a young Egyptian archaeologist named Kamal el-Malak was supervising a routine clearing of sand and debris from the area along the southern face of the Great Pyramid. As his team worked to clear a path for a new tourist road, their tools struck something hard beneath the surface. It was not bedrock, but a long, straight, and clearly man-made line of massive limestone roofing blocks. As they cleared the sand away, they revealed a row of 42 colossal limestone beams, each weighing nearly 15 tons, fitted together with a plaster mortar to create a perfect, airtight seal. For 4,500 years, this immense stone lid had remained completely undisturbed, its existence a total secret. With a feeling of immense anticipation, El Malak and his team spent weeks carefully drilling a small hole through one of these massive blocks. Finally, the drill bit broke through into a void below. He would later write that when he peered into this small hole, his first sensation was not one of sight, but of smell. He was struck by the faint but unmistakable and sacred scent of ancient cedar wood, a fragrance that had been trapped in the darkness for 45 centuries. When the team finally summoned the immense lifting power required to raise the 15-ton roofing blocks one by one, they were met with a sight of almost unbelievable preservation and profound mystery. Deep within the rock-cut pit below, they did not find an assembled, intact ship. Instead, they found what can only be described as the world's largest, oldest, and most complex model kit. The great boat had been deliberately and meticulously disassembled into 1,224 individual and almost perfectly preserved wooden components. The massive planks of the hull, the graceful oars, the deck house, the canopy, every single piece of the great vessel was present, laid out in a precise and carefully ordered sequence within the pit. It was an act of profound and ritualistic deconstruction. This discovery presented the restorers with a three-dimensional puzzle of an almost unimaginable complexity. They had to somehow reassemble this ancient, colossal, and deeply alien watercraft with no plans, no diagrams, and no instructions, a process that would require more than a decade of painstaking and often frustrating research and experimentation. The long and arduous task of this great reassembly, led by the master restorer Ahmed Youssef Mustafa, revealed the secrets of a completely lost and brilliantly ingenious school of naval architecture. The Khufu ship, as it has come to be known, was not built in a way that any modern shipwright would recognize. A modern wooden boat is built from the inside out. A strong internal skeleton or frame is built first, and the planks of the hull are then attached to it with nails, pegs, or screws. The Khufu ship was built from the outside in. It is a shell-first construction, with no internal frame. Its immense thick planks of Lebanese cedar wood were first carved and shaped to fit together with an almost perfect precision. And then in the most remarkable feature of its design, these massive planks were literally stitched together from the inside. A series of complex V-shaped channels were carved into the interior faces of the planks, and thousands of meters of strong twisted rope made from hoffa grass were then painstakingly threaded through these channels, lashing the planks to one another in a strong and intricate pattern. This technique meant that the smooth, sleek, and perfectly finished exterior of the hull showed no signs of any nails, no pegs, and no stitches at all. This remarkable stitched construction was then brought to its final state of strength and integrity by the power of water itself. The final brilliant secret of this lost shipbuilding technology was its reliance on the natural properties of the wood. After the thousands of individual stitches had been tied, the great boat would have been placed in the waters of the Nile. The dry imported cedar wood would have immediately begun to absorb the water, causing the massive planks to swell and expand. This swelling would have had two critical effects. Firstly, it would have tightened the thousands of rope stitches to an incredible, almost unbreakable tension, pulling the entire structure together with immense force. And secondly, it would have caused the precisely carved and shaped edges of the planks to press against one another with such power that they would form a series of perfect watertight seals. It was a form of active hydraulic engineering, a process where the ancient shipwrights cleverly used the very element that the boat was designed to travel upon, the water itself, to complete the final, critical, and powerful assembly of their magnificent creation. The profound question, of course, is what was the purpose of this magnificent and technologically advanced vessel? Why was it so carefully and ritually disassembled and buried in its own royal tomb at the foot of the Great Pyramid? The answer lies deep within the complex cosmology of ancient Egyptian religious belief. The first and more literal theory is that this was the actual funerary bark, a real-world vessel that was used to carry the mummified body of the pharaoh Khufu, along with his funeral procession on his final earthly journey from his royal palace at Memphis to the great necropolis at Giza. The second and more widely accepted theory is that this was a purely religious object, a magical vessel known as a solar bark. The ancient Egyptians believed that the great sun god Ra traversed the sky each day in a great ship, a bark of the morning, and then, each night, he would sail through the dark, dangerous, and demon-haunted underworld in a bark of the evening, a journey that was essential for him to be reborn, triumphant, at dawn. This great buried ship was therefore a full-scale and fully functional magical vessel, placed there so that the spirit of the deceased pharaoh could take his rightful place at the side of the sun god, accompanying him on his eternal, daily, and nightly cosmic journey, thus ensuring not only his own divine resurrection, but the continued stability of the entire cosmos. This magnificent, silent, and perfectly preserved vessel, a true masterpiece of a lost and forgotten art of shipbuilding, adds another profound and deeply human layer of complexity and meaning to the great funerary machine of the Giza Plateau. It is a powerful and moving testament to a civilization that applied the very same, almost fanatical level of precision, of craftsmanship, and of deep symbolic purpose to the beautiful objects that would accompany their divine king into the afterlife, as they did to the colossal and eternal stone monument that would serve as his final home. But the great pyramids of Giza, for all of their unique and superlative fame, are not the beginning of this incredible story. They are not a sudden, inexplicable flash of genius that appeared out of nowhere. They are, in fact, the magnificent and final culmination of a long, a difficult, and an often dangerous evolutionary process. Where did this incredible and seemingly perfect architectural and engineering knowledge come from? What were the earlier, the experimental, and in some cases the almost disastrous attempts at pyramid building that served as the necessary and often humbling schoolrooms for the great master builders of Giza? To truly understand the perfection of Khufu's great monument, we must now travel back in time to the earlier and in some ways even more mysterious pyramids that came before it. The great and magnificent pyramids of the Giza Plateau were not a sudden and inexplicable miracle. They did not spring fully formed and perfect from the mind of a single architect. They are in fact the stunning and final culmination of a long and arduous and a deeply instructive century of architectural and engineering evolution. They are the final, perfected version of a monumental idea that was developed over several generations through a process of bold experimentation, of brilliant innovation, and of sometimes catastrophic and humbling real-world failure. The incredible and seemingly effortless perfection of the Great Pyramid of Khufu is a direct result of the hard-won lessons that were learned by the kings and the builders who came before him. To truly understand the genius of Giza, we must first walk the path of their predecessors and explore the crucial and often flawed prototypes that served as their essential schoolrooms. The genesis of the pyramid, the very first seed of this colossal idea, is to be found in a much simpler and more ancient form of royal tomb, the mastaba. For centuries before the first pyramid was ever conceived, the kings and the nobles of Egypt were buried in these massive, single-story, rectangular structures with flat roofs and gently sloping sides. The word mastaba is the Arabic word for bench, and these tombs do indeed resemble huge bench-like structures of mud brick, or later of stone, resting upon the desert surface. The true function of the mastaba, however, was subterranean. It was a large protective monument that was built directly over a deep, rock-cut shaft that led down to the sealed and hidden burial chamber of the deceased. For generations, this was the standard and unchanging form of the royal tomb. It was a structure that was fundamentally connected to the earth, a monument that was designed to be imposing, but which never made any great attempt to reach for the sky. The first, and perhaps the single greatest revolutionary leap in the history of all architecture occurred around the year 2650 BC, during the reign of the pharaoh Djoser. The architect of this revolution was the king's vizier and high priest, a man of almost mythical genius, named Imhotep. It was Imhotep who conceived of a completely new and radical idea. Instead of building a single traditional mastaba for his king, he began by building one, and then, in a series of inspired additions, he proceeded to stack 5 more, progressively smaller mastabas, one on top of the other. The result was the world's first pyramid, the Great Step Pyramid of Saqqara. This was not just a profound conceptual leap, a symbolic transformation of the tomb from a simple bench on the earth to a great 6-stepped stone stairway to the heavens. It was also the first time in human history that stone was used on such a massive and monumental scale, a project that required the invention of entirely new techniques for quarrying, for transporting, and for lifting, and which represents the very birth of all stone-cut architecture. Following the brilliant innovation of Imhotep, the next great chapter in the evolution of the pyramid was dominated by a single, powerful, and incredibly ambitious pharaoh, Sneferu, the father of Khufu, the builder of the Great Pyramid. Sneferu was the greatest pyramid builder in all of Egyptian history, and his reign was a period of intense and sometimes disastrous experimentation. His first attempt to build a new kind of monument was at the site of Meidum. Here, he constructed a large 8-stepped pyramid. But then, a second and even more radical idea was attempted. The builders decided to try to transform this step structure into the world's first true smooth-sided pyramid. They began the process of filling in the great steps with a packing of stone, and then encasing the entire structure in a smooth angled skin of polished white Tura limestone. But this experiment ended in a catastrophic failure. Modern analysis suggests that the outer casing was not properly bonded to the inner core of the step pyramid. The foundations were also unstable. At some point, either during the construction or shortly after, the immense weight of this outer shell caused it to collapse, and the entire casing slid down into a colossal mountain of rubble at the pyramid's base, leaving only the strange, tower-like and heavily ruined inner core that we see today. Undeterred by this colossal failure, Sneferu abandoned the site of Meidum and moved his royal necropolis to a new and more geologically stable site at Dashur. Here he began his second and even more ambitious attempt to build a true pyramid. This is the monument that is known today as the Bent Pyramid, one of the most unique and strangely beautiful structures in all of Egypt. The builders, clearly still confident, began the construction at a very steep and ambitious angle of 54 degrees. But as the pyramid rose to about half its intended height, it is almost certain that the engineers began to see terrifying signs of structural distress. Cracks began to appear in the ceilings and the walls of the internal chambers, a clear and ominous warning that the immense weight of the structure was causing the foundation to fail, and that the steep angle of the sides was creating an unsustainable level of internal pressure. In a desperate and unprecedented mid-construction course correction, they made a radical decision. They suddenly and dramatically changed the angle of the upper half of the pyramid to a far safer and more stable 43 degrees. This emergency redesign is the reason for the pyramid's iconic and accidentally beautiful bent appearance. The bent pyramid is, in many ways, the most important and the most instructive of all the pyramids. It is a unique architectural fossil, a monument that preserves in its very stones a moment of profound real-time engineering crisis and of the brilliant adaptive problem-solving that was used to overcome it. The near disaster at Dashur taught Sneferu's builders two vital and hard-won lessons that would pave the way for the perfection of Giza. The first was a new and profound respect for the immense compressive forces at play, and the critical importance of building at a safer, more stable angle of slope. The second was the development of a new and far more stable method of construction for the core of the pyramid, in which the blocks were now laid not in horizontal courses, but in courses that sloped slightly inwards, towards the center of the pyramid, a technique which dramatically increased the structure's internal stability. The bent pyramid is also remarkable for one other reason. It is the pyramid that retains more of its original, polished white limestone casing than any other in all of Egypt, giving us our most complete and breathtaking glimpse of the original, dazzling splendor of these ancient monuments, with the invaluable and almost catastrophic lessons from two partial failures now fully understood. Sneferu, in the final years of his long reign, embarked on his third and final monumental project, also at the site of Dashur. This is the monument that is known as the Red Pyramid. Here, the great master builders of the Fourth Dynasty applied all of their hard-won knowledge. They chose a site with a solid, stable foundation. They began the construction. From the very first course, using the new, safer, and more stable 43-degree angle of slope that they had been forced to adopt on the bent pyramid, and they perfected the technique of laying the internal core blocks in a gently sloping, inward-leaning orientation. The result was a stunning and unqualified success. The Red Pyramid is the world's first large-scale and perfect, true smooth-sided pyramid. Its beautiful and almost perfect geometry, and its warm reddish hue, from which it derives its modern name, make it a serene and deeply impressive monument. It is the final and successful prototype, the magnificent culmination of Sneferu's long and difficult apprenticeship, and the direct and immediate architectural and engineering predecessor to the even grander and more perfect monument that his son Khufu would soon go on to build on the Giza Plateau. This remarkable and profoundly instructive century-long journey of architectural and engineering evolution, this story of a great and simple idea that was slowly and painfully refined through a process of bold innovation, of catastrophic failure, of brilliant adaptation, and of final triumphant success, is the hidden and essential prequel to the story of the Great Pyramid of Giza. The most famous monument on earth was not a sudden miracle. It was the magnificent and final result of a long, a difficult, and a deeply human apprenticeship with the unforgiving laws of physics and the fundamental nature of stone. But throughout this entire generational history of monumental construction, a single, central, and all-powerful figure has been ever present but has so far remained in the shadows: the pharaoh himself. What was the true nature of the king in ancient Egypt that could inspire such a colossal and almost bankrupting national effort? An effort that was directed almost entirely towards the construction of his tomb. To truly understand the incredible engineering of the pyramids, we must finally seek to understand the profound, the absolute, and the deeply otherworldly religious and political beliefs that were its ultimate and its all-powerful driving force. To attempt to understand the Great Pyramid as a purely structural or logistical achievement is to see only the shadow of the object, and to miss its true luminous substance. The immense, almost fanatical investment of time, of resources, and of human life into the construction of these great monuments is something that cannot be explained by the simple desire of a king to build a large tomb. The forces that raised these mountains of stone were not just physical, they were metaphysical. The pyramids are the colossal and inevitable, physical manifestation of a deeply held and all-encompassing religious and political belief system. To the ancient Egyptians, the pyramid was not just a building, it was a machine for resurrection. It was an engine of cosmic stability. It was a profound and powerful piece of theological technology, designed and built with the express purpose of upholding the very fabric of the universe. The almost superhuman effort of the builders can only be understood when we realize that they were not just working for a king, they were working for a god, and for the continued existence of the world itself. At the very center of this belief system stood the figure of the pharaoh. The king of Egypt was not a mere mortal ruler who was chosen by the gods. He was understood to be a living god on earth. He was the direct physical incarnation of the great celestial deity, the falcon-headed god Horus. He was the sole and essential intermediary between the world of humanity and the world of the gods. The Egyptians believed that the king had two bodies, the mortal, physical body of the individual man who held the throne, and the eternal, divine, and unchanging spiritual body of the kingship itself. The death of the pharaoh was, therefore, an event of immense danger and cosmic significance. It was a moment of profound transition, a time when the divine essence of the kingship had to be safely and successfully transferred from its deceased mortal vessel to the new one, the king's successor. The pyramid was the great stone-built instrument that was designed to facilitate and to protect this perilous and absolutely essential moment of divine transference. To comprehend the function of this great instrument, one must first understand the ancient Egyptian conception of the soul. They believed that the human spirit was a complex, multifaceted entity, comprised of many different parts. The two most important of these, for the purposes of the afterlife, were the Ka and the Ba. The Ka was the vital life force of an individual, a sort of spiritual double that was created at birth, and which after death continued to live on within the tomb. But this Ka needed to be sustained for all of eternity with a constant supply of offerings of food, of drink, and of prayer. The Ba was closer to our concept of the individual personality, the unique character of a person, and it was often depicted as a human-headed bird. The Ba was believed to be able to travel, to leave the tomb during the day, and to fly out into the world of the living. But it was required to return each and every night to the safety of the deceased's physical body within the tomb. The pyramid, therefore, was not just a tomb, it was the permanent, the indestructible, and the eternal home for the Ka, and the one essential and unchangeable anchor point to which the far-ranging Ba could always safely return. The successful preservation of the king's soul, however, was not just a matter of his own personal salvation. It was an event of universal importance. The central concept in all of Egyptian thought was the idea of Ma'at. This was the fundamental and sacred principle of cosmic order, of truth, of justice, of balance, and of harmony. The Egyptians believed that the universe had been created in a state of perfect, divine order, but that this order was constantly under threat from the ever-present forces of chaos, of darkness, and of decay. The single most important and sacred duty of the pharaoh, as the living god on earth, was to be the champion and the guardian of Ma'at. His every action, his every ritual, was designed to uphold this fragile cosmic balance. His death, therefore, represented a moment of profound cosmic danger, a potential victory for the forces of chaos. The king's successful transition to the afterlife, his rebirth as a divine being among the gods, was seen as absolutely essential for the preservation of Ma'at for the entire world, an act that would guarantee the continued orderly rising of the sun, the predictable and life-giving annual flooding of the river Nile, and the continued stability and prosperity of the Egyptian kingdom. The pyramid, then, was the ultimate machine for upholding Ma'at. It was a multifaceted, symbolic, and architectural engine designed to guarantee the king's successful resurrection. Its very shape was a source of immense magical power. It was a physical representation of the Benben, the mythical primordial mound that was believed to have emerged from the chaotic waters of creation at the beginning of time and upon which the creator god first appeared. To be buried within the pyramid was, therefore, to be placed within the very heart of creation itself, a powerful symbol of rebirth. Its form was also a great stone stairway to the heavens, a physical ramp upon which the soul of the king could ascend to take his rightful place among the circumpolar stars in the northern sky, the stars that never set and were therefore known to the Egyptians as the imperishable ones. And at the same time, its shape was a representation of the petrified, descending rays of the sun god Ra, a tangible pathway of light that would allow the king to join the sun god on his eternal, daily journey across the sky in his great solar bark. The construction of this colossal and indispensable engine of cosmic stability was, without question, the central and defining project of the Old Kingdom civilization. The entire economic, political, and social structure of the nation was, for over a century, geared towards the single, all-consuming goal of constructing the royal necropolis. A vast and continuous river of the nation's wealth was funneled into these monumental projects. The agricultural surplus of the entire Nile Valley, the taxes that were collected in the form of grain and of livestock, were all used to fuel the immense army of workers. The nation's greatest minds, its most skilled artisans, and a significant portion of its entire labor force were all conscripted into this single, generational task. This was not a simple act of vanity. It was the central, state-sponsored religious and economic undertaking of their time, a project that was seen as being just as essential for the nation's survival as the harvest or the defense of its borders. It was the price that an entire civilization was willing to pay for the preservation of cosmic order and for the guarantee of eternity. This profound, this complex, and this all-encompassing belief system, a worldview that placed the divine and immortal king at the very center of a fragile and constantly threatened cosmic order, is the only force that is powerful enough to explain the almost superhuman and sustained effort of the Great Pyramid builders. They were not just building a tomb for a dead king, they were building a machine of state, a theological instrument that was designed to hold back the forces of chaos and to uphold the very fabric of the created universe. But with the end of the Great Fourth Dynasty, the age of Khufu, Khafre, and Menkaure, the era of the most colossal and perfect pyramid building came to a relatively abrupt and dramatic end. Why did the Egyptians stop building on such an immense and almost bankrupting scale? What were the economic, the political, and the religious shifts in their society that led to the slow decline of this monumental tradition? And what new and even more secret forms did the royal tomb take in the centuries and the millennia that followed? This leads us to the final chapters of our long story, the slow and lingering twilight of the pyramids, and the new and even more ingenious forms of hidden tombs that would eventually come to replace them. The great and perfect pyramids of the Giza Plateau represent the absolute and undisputed zenith of a colossal architectural and engineering tradition. They are the magnificent and final statement of an age of almost unimaginable ambition and of a society that possessed an almost absolute unity of purpose. But this golden age, this brief and brilliant period of the Great Fourth Dynasty, was not to last. The construction of these monuments on such a colossal and almost bankrupting scale was an effort that could not be sustained forever. In the centuries that followed the reigns of Khufu, Khafre, and Menkaure, the great age of the pyramid builders began its slow, long, and irreversible decline. This was not a sudden collapse of knowledge or of skill, but a gradual and complex transformation, a slow twilight that was brought about by a confluence of immense economic strain, of shifting political power, and of a profound and fundamental evolution in the religious beliefs of the Egyptian people. The sheer staggering economic burden of the Giza necropolis is a factor that cannot be overstated. The construction of these three great monuments, and their vast attendant complexes of temples, of causeways, and of satellite tombs, represented a continuous, century-long mobilization of the entire economic and human resources of the Old Kingdom. A vast and significant portion of the nation's total gross domestic product, its agricultural surplus, its mineral wealth, and its skilled and unskilled labor, was funneled, year after year, into the single all-consuming task of building the king's eternal home. Furthermore, upon the death of each king, a vast estate of agricultural land was endowed, in perpetuity, to support the mortuary cult, the generations of priests and servants who were required to perform the daily rituals and provide the offerings for the deceased king's soul. Over time, this meant that an ever-increasing percentage of the nation's most fertile land was falling under the control of these tax-exempt religious foundations, placing a continuous and growing strain on the central authority and the economic power of the living pharaoh. This slow drain of wealth and power away from the throne was accompanied by a gradual but significant shift in the religious landscape of ancient Egypt. During the 5th and 6th dynasties, the centuries that followed the Giza builders, the cult of the great sun god Ra, whose center of worship was at the city of Heliopolis, began to grow to a position of unprecedented power and influence. As the priesthood of Ra accumulated more wealth, more land, and more political authority, the absolute and previously unquestioned divine authority of the pharaoh as a god in his own right began to subtly wane. This shift is written directly into the stone of the pyramids of this later era, which are found at the sites of Abu Sir and Saqqara. They are dramatically smaller than their Giza predecessors, and they were constructed with a far less durable and far less expensive internal core of small, rough stones and mud brick. They were in essence cheaper, faster, and less resource-intensive monuments to build, a clear and undeniable architectural signal of the changing economic and political realities of the kingdom. But perhaps the most powerful driver of this great architectural change was the slow dawning and deeply troubling realization that the pyramids, for all of their colossal size, for all of their internal complexity, and for all of their ingenious security features, had failed in their single, most fundamental, and most sacred purpose, to protect the body of the deceased king and the treasures that were buried with him for all of eternity. The Great Pyramid was a fortress, but it was a fortress that, by its very nature, sent an unmistakable and irresistible message across the desert. Its immense and obvious form was a colossal and permanent advertisement for the unimaginable wealth that was hidden within its heart. And so, despite the immense, sliding granite plugs, despite the hidden entrances and the complex internal passages, it is now almost certain that every single one of the great pyramids of the Old Kingdom was broken into and comprehensively plundered by ancient tomb robbers, in some cases within only a few generations of the king's burial. This profound and repeated failure of the Great Pyramid as a secure eternal home led over a long period of time to a complete and radical shift in the entire philosophy of royal burial. If a monument of almost unimaginable size and strength could not provide true security against the ingenuity and the greed of man, then the only other viable strategy was one of complete and utter secrecy. The central goal of the royal tomb was no longer to create a great, visible, and monumental stairway to the heavens that would dominate the landscape. The new and far more practical imperative was to create a secret, a hidden, and a magically protected resting place, a house of eternity that was completely invisible from the surface, a tomb whose greatest and only true security would be the fact that no one could ever find it. The age of the great, proud, and visible monument was over. The age of the deep, and the hidden, and the secret tomb was about to begin. This new philosophy found its ultimate expression 1,000 years after the Giza pyramids, in the great royal necropolis of the New Kingdom, the legendary Valley of the Kings, located hundreds of miles to the south of Giza, in the desolate, sun-blasted, and theatrical landscape of the Theban Hills, on the west bank of the Nile, opposite the great capital city of Thebes. This remote and easily guarded desert valley was chosen as the new and secret burial ground for the greatest pharaohs of the Egyptian Empire. The tombs themselves were a complete inversion of the pyramid concept. There were no superstructures at all. The tombs of the New Kingdom are a series of deep, rock-cut corridors, staircases, and chambers that plunge in some cases for hundreds of meters deep into the living, solid rock of the valley walls. They are, in essence, man-made caves, designed to be sealed and hidden so perfectly after the king's burial that their entrances would simply disappear back into the surrounding landscape of the valley. With all of the architectural and artistic effort now removed from the exterior of the tomb, it was instead focused with a breathtaking and brilliant intensity on the interior. The walls and ceilings of these deep hidden corridors and burial chambers were covered, from top to bottom, with the most intricate, the most complex, and the most brilliantly colored paintings and carved reliefs in all of ancient Egyptian art. But these were not just decorations. The tomb's interior was a complete, three-dimensional, and magical guidebook to the afterlife. The walls were covered with the sacred texts of the great funerary books, such as the Book of the Dead and the Amduat, which provided the soul of the deceased king with the spells, the maps, and the secret knowledge that he would need to safely navigate the terrifying and perilous journey through the 12 hours of the night, the dark and demon-haunted underworld, and to finally achieve his triumphant and glorious rebirth with the rising sun each morning. This profound and radical shift, from the colossal, the proud, and the ultimately insecure visible monument of the Old Kingdom, to the deep, the secret, and the magically protected hidden tombs of the New Kingdom, represents the final and complete evolution in the long and complex story of the pharaoh's eternal home, the great and magnificent engineering of the pyramid, the lost and epic art of building man-made mountains, was ultimately abandoned in favor of a new and in many ways more subtle and more intricate engineering of perfect concealment. And yet, for all of the millennia that have followed, the Great Pyramids of Giza have remained, their secrets largely intact, their true purpose debated, and their immense, silent presence continuing to dominate not only the desert landscape, but the very imagination of all of humanity. In our modern era, a new kind of explorer has finally arrived, an explorer that is armed not with copper chisels or with brute force, but with cosmic rays, with ground-penetrating radar, with infrared thermography, and with miniature robotics. What new and perhaps final secrets are these silent, ancient mountains now beginning to reveal to us? What hidden chambers and unknown empty voids are now being discovered through the penetrating and non-invasive lens of 21st century science? And what might they tell us about the last, the greatest, and the most enduring unanswered questions of how and why they were ever built at all?